Good day everyone. Today I'm going to explain about the problems on drying and ventilation system and covering the slope analysis for ceramic drying heat needed for an industrial dryer. So first problem. A ceramic drying process uses air initially at 15 degrees Celsius and 60% relative humidity. The air is heated to 45 degrees Celsius then pass over wet ceramics until it reaches 30 degrees Celsius. We need to find the slope of the drying process line on a Mollier diagram and check the error if we assume an isenthalpic process. So to find the slope, we use the formula Cp delta T plus Cp times temperature over HFG. So plugging in the numbers, air specific heat is 1.006, delta T is 15, and specific heat is 1.88, material temperature is 20, and latent heat of vaporization is 2430 kilojoules per kilogram. So it gives us the slope about 37.6. So for the HOTS, if we assume an isenthalpic process where the slope is 0, we'd get a different final humidity. The actual error from the shortcut is only 1.54, so it's close but not exact. For problem number 2, an industrial dryer makes intake air at 10 degrees Celsius saturated and needs to remove 50 kg per hour of moisture. The specific heat consumption is 3,500 kilojoules per kilogram, and we need to find the required heating coil capacity in kilowatts and discuss if increasing preheat by 10 degrees Celsius helps. So by solving this, the total heat needed per hour is 50 times 3,500, which is equal to 175,000 kilojoules per hour. Then we will convert the hour into seconds to get the unit of kilowatts. So 175,000 kilojoules per hour times 3,000 seconds over 1 hour, then cancel out the unit H to get the seconds. Then kilojoules per second is simply kilowatts. So now our answer is 48.6 kilowatts. That's the minimum heating coil capacity needed, and increasing preheat by 10 degrees Celsius does not help a bit, but most of that extra heat just leaves with an exhaust as waste. So for the last number, a leather drying room is kept at 100 degree Fahrenheit and 40% relative humidity. An exhaust fan removes 1,500 cubic foot per minute, and makeup air comes in at 20 degree Fahrenheit and 30% relative humidity. We need to find the moisture load added by the fan and check if a 200,000 BTU per hour heater is enough. So first, we find the mass flow rate. 1,500 CFM times 60, it gives us 90,000 cubic foot per hour. Then divide it by the specific volume, which is 14.5. So we can get the answer of 6,206.9 or 6,207 for round up pounds per hour of air. So the next, the moisture load. The room has a humidity ratio of 0.0165, while the makeup air is only 0.00064. The difference times the mass of the flow gives us a humidification load of about 98.7 pounds per hour. So for heating, room air is 42.5 BTU per pounds and makeup air is 5 BTU per pounds. Then multiply the difference by the mass flow, and then we can get the answer of 232,750 BTU per hour needed just for that fan. So if the system supplies only 200,000 per hour BTU per hour, it's short, so the fan adds a significant load to run this object.